All right. I'm assuming some students are already preparing for the AP Pre-Calculus exam. I'm preparing some of my students I'm tutoring right now, so I thought this would be helpful. This is just a problem taken from the website crackap.com. This is free response practice test number 3. Okay. I'm going to solve it live, and maybe I've done this before in previous videos. Maybe I'm solving it or thinking of it in a different way than the solution on the website does. So hopefully this can be helpful if you if the website didn't help or you want to see another way to think about it. But maybe I'm approaching the problem the exact same way as the website. We'll see. Okay. So this guy says, given the function f of x is negative, 7x minus 14 squared, 10x plus 80 cubed, we want to state the degree of f, okay? So the degree, what is the degree? It's the largest power of x. We have to remember that concept, okay? For polynomials, it's the largest power of x, okay? So if you expand everything out, we're not going to do it. We would have to expand the square out, and we have to expand this cube out, and then we would have to do a lot more distributing and all that. What would the biggest power of x be? It'll be some coefficient out in front, x to the what power? It'll be to the 5th power, okay? Because from the squared, you'll have something x squared, and over here, the biggest degree will be something x cubed, and then when you multiply those two polynomials together, you'll get the x to the 5th. So the degree is 5. Okay, that's part A. Part B, find the zeros of f along with their multiplicities. Okay, given the constraint I have, I did not set this up well. Don't want to start filming again. I'm going to erase that. Okay. The zeros along with the multiplicity. So basically, we want to set, it's part B, we want to set f of x be equal to 0 when the y value is 0. Okay, so what is that? Minus, parentheses, 7x minus 14 squared, 10x plus 80 squared. This, by the way, this website doesn't have like scoring guidelines like the actual AP exam gives when they give out the solutions. So in the interest of trying to get all the points possible, write out your steps. Okay, don't skip steps. Okay, important steps. I'll let you think what's important. Okay, so this is a critical step. We want to set the function equal to 0. So we use the thing called the zero product property. So 7x minus 14 can be 0, or 10x plus 80 can be 0. Okay, so then 7x is 14, x is equal to 2. This is 10x is negative 80, x is negative 8. Okay, now what are the multiplicities? This is a cube, I copied it wrong. Okay, the multiplicities, what does multiplicity mean? It means a repeated 0. Okay, this 0 corresponding to x is equal to 2. There's 2 of them because it's 7x minus 14 times 7x minus 14. There's 2 of them. So this has a multiplicity of 2. And this guy, x is negative 8. Well, there's 3 of the 10x plus 80s. Okay, so it has a multiplicity of 3. Here's the 2 things that we need. Okay. By the way, I should be checking my answer. I do have the website snipped. Well, actually, it's on the second page as well. So degree is 5, as we were saying, and 2 and negative 8 for x is 2, multiplicity is 2, negative 8, x is negative 8, the multiplicity is 3. Exactly what I got. Okay, cool. Okay, let's erase. All right. State the values of x for which the graph of f is tangent to the x-axis and justify your answer. Okay. What does tangent to the x-axis mean, first of all? Let's visualize it. Here's the x-axis. When it's tangent to the x-axis, that means it only touches it one time and it's perpendicular there. Sorry, not perpendicular. It just touches it once. Okay, something like that. So why is it asking this question? Let's think about it. It has to do with part B. Because if you remember, when there's an even multiplicity, you can also look at that, by the way. It doesn't cross the x-axis. When there's an odd multiplicity, it crosses. You look like that or that. That's how it's related to part B. So state the values for which x is tangent to the x-axis. So when it touches the x-axis, it's a 0, clearly. But if it doesn't cross, then that's when it's tangent, okay? So, as I was saying, when it's even multiplicity, when it's 0 is even multiplicity, that's when it doesn't cross. So the value for x would be x is equal to, it was this one over here. That's x is equal to 2. So we can even say because even multiplicity. Actually, we have to say it because it says justify your answer. Okay, let's see what the answer said. X is equal to even multiplicity. There we go. Okay. Cool. So far I'm approaching it pretty much the exact same way as the posted solution is. Okay, evaluate limit as x approaches negative infinity and limit as x approaches infinity. Okay, this is hopefully simple enough. Okay, so how can we go about this? Well, when we kind of plug in negative infinity to this first term, what's the sign? Is it negative or positive? Well, it's something squared, right? So it's going to be positive, okay? And by the way, we have the negative from up here, so I'm going to write it as well, okay? And then when we plug in negative infinity over here, what do we get? Do we get a positive guy or negative guy? Well, it would be some huge negative number. If I plug in negative infinity here, huge negative number plus 80, that's insignificant. So it'll be negative number cubed, which is negative. So this would approach positive infinity. Okay, this is a polynomial, so it will either go to positive or negative infinity. Okay, and since this is an odd degree, remember part A, so one n is going to go to positive infinity, one n is going to go to negative infinity. So by that logic, we can already get that as x approaches positive infinity, this will be negative infinity, okay? But let's do the same process to confirm. We have the negative from the negative sign, okay? When we plug in positive into the second guy, we get some huge positive number, minus 14. That minus 14 is insignificant. We square it, that becomes positive. When we plug in a huge positive number into here, let me write the arrow again, then that is positive plus 80, so that becomes more positive. We cubed it, that is positive. So you can see that that's why that one is negative infinity. Okay, this is one way to go about it. Okay, let's see what the answer key said. Maybe they actually did something else. Let's see. Is determine the end behavior, as I said, polynomial by the degree and the leading coefficient. You could do that as well. Okay, so let me explain what's going on here as well. Okay. The leading coefficient, so it'll be something x to the fifth. That was the degree, right? Well, when we expand these two out, it will be some positive number. And then we have that negative right here still. Some positive, some value. No, let's not put 0. Let's put like C for some number, okay? So for x to the fifth, as I was saying, one n will go to negative infinity, one n will go to positive infinity, but then there's this negative over here, so we flip it. So it looks something like that. So this is one way to think about it as well. Honestly, I don't like to think about it this way. I like to just do the plug-in method. Okay, especially if it's in factored form. Okay, if it's an expanded form, then you can use the thought process I just explained. Let me go over it one more time. Okay, it'll be negative some number x to the fifth. So as x keeps bigger and getting bigger and bigger, by the way, the lower degree terms, like x something x to the fourth, imagine a million to the fifth power versus a million to the fourth power. Which one is much bigger? It's a million to the fifth power. So that's why the lower degree terms don't even matter. They're insignificant, okay? Now, as x approaches positive infinity, well, these will be positive, but then there's a negative, right? So that's why it's negative infinity. And then as x approaches negative infinity, well, negative to the fifth power gives us negative. Two negatives make a positive. Okay, that's the other way to go about it. All right, enough on that one. Now let's use parts A through D to sketch this function. Okay. Let me draw my axes first. Okay. So we said that there were zeros at, what was it? At 2. And it should not cross. It should go something like this. It'll be tangent because it's an even multiplicity. And at -8, let me expand it more. There's one there, and then it crosses, okay? So, and as we were saying, as x approaches negative infinity, it should be going to positive infinity. So from the 0, it should be going to positive infinity, okay? And then these are the only 2 zeros, right? Actually, would it be over there or would it be over here? Because after the 0 should go to negative infinity, right? So then it'll be tangent in this way. And then this will make sense because there's no other 0, so it can't cross above the x-axis. So it'll look something like this. Okay, let's look at the answer key. Yep, about right. Okay, so again, let me explain what I was thinking. Okay, so x is equal to 2, we know that it should not cross the x-axis. It should only touch it. So it either looks like this or it looks something like this. We know that it's going to be this, the one that this shape over here, because as x approaches positive infinity, we know that it goes to negative infinity. So that's why this one would work. This one approaches to positive infinity, right? So it'll be this way, and then it will not cross. It will like do a boomerang or a bump or whatever your teacher likes to call it, okay? And then over here, similarly, at this 0, it does cross because it's an odd multiplicity, as we were saying. And as x approaches negative infinity, it goes to positive infinity. So as we get more and more negative in the x, the y value approaches positive infinity, okay? Now, what about in between? Well, we know that it cannot cross the x-axis again because there's no more zeros. Those were our 2 zeros, these at -8 and 2. So it has to stay underneath the x-axis because, as I was saying, at -8, it should cross, and at 2, it should do the bump thing or whatever you want to call it. So that's why it looks like that. All right. That's it for this one. Hopefully this is a good review if you totally forgot about polynomials and stuff like that. All right. Stay tuned for another practice problem video.